Hi, I'm John at Coach Slade Tutoring, and today we're looking at a problem that afflicts thousands of people who are learning to code, and that is tutorial hell. We'll look at what tutorial hell is, how can you define it, and it's kind of almost a disease of learning. It's a dysfunctional way to learn to code. So what are the symptoms of that disease? We'll also look at an example tutorial user who's going to kind of show us the source of some of those problems. We'll look at why people keep going back to tutorials, and for D, and D is really the core of this talk, the most important part, D is looking at the causes of those symptoms and solutions to those problems. And finally, for E, we'll look at how you can take your learning a step further. Let's get started. So what exactly do I mean by tutorial hell? Now, this is not a scientific or academic term. It's just something people talk about online a lot. Something I do in my quest as a computer science educator is I read different subreddits and discords that have people talking about problems they're facing as they're learning to code, and this topic shows up at least once a week. It's a very common and very frustrating problem that lots of people have, but it's not a scientific or academic term. So what do I mean here? Number one, a person spends many hours, perhaps hundreds of hours, going through tutorials, but they're unable to apply what they've learned to real problems, to other problems, to their own projects, and so on, and they kind of feel after spending hundreds of hours that they've learned nothing. Number two is the paradoxical part. They feel they don't know enough, but instead of kind of saying, this way of learning does not seem to be effective, they just go back for more tutorials, thus continuing the cycle. Now, this talk, a couple things, is not about career stuff. If you're looking for career information, not about that. It's about the learning process. And actually, I think people can get a lot of value from online tutorials, and they're an excellent resource. However, you need to be careful in certain ways that we will go over. So tutorial hell is almost like this movie Groundhog Day. In the movie, the main character, played by Bill Murray, wakes up and the same day is always happening. It's always this specific day, Groundhog Day, on the calendar, and it's the same thing over and over, and he can't escape that. So tutorial hell is like people are doing different tutorials over and over and over, but they feel like they make no real progress. So here's some quotes about tutorial hell that are kind of going to show us how people feel. And these may be things that you feel. If you're watching this on YouTube, go ahead and tell me which one of these you feel in the comments. I feel A, I feel B, I feel all of these. But let's just read these over. These are different quotes I pulled mostly off Reddit where people are discussing this. A, I finished the tutorial and understood everything, but then I can't do anything with it. B, when I go to write code, I can't remember anything, or maybe one simple thing, but that's it. C, I couldn't figure it out, so I looked at the solution, and they call this random function, and it's like, how am I supposed to know that that's what I should do there? And D is a big one. D is maybe the worst. C and D, I think, are the worst. Whenever I see other projects, I have no idea where to even start. So I really think each of these quotes kind of shows a different symptom of this dysfunctional way of learning using tutorials. A, the illusion of competence, right? They feel like they're learning something, but in fact, that feeling may be mistaken. There's a mismatch between what they've really acquired and what they feel like they've acquired. B is just poor recall. This is just sort of a way of saying you don't remember and you can't pull up the proper information at an appropriate time. And A and B have fairly well-researched ways to get around these problems. C is not knowing where to apply these concepts or the functions you're learning, the framework you're learning, the syntax you're learning, and so on. You're not being properly trained or properly learning where to apply these things, because really it probably wasn't a completely random function. It's something that maybe they showed you a few modules ago, and you're just not spotting it, right? Now, sometimes there are things that come out of nowhere. That does happen, but for the most part, I really think C is a failure to learn how to recognize situations where to apply these things. And finally, D. I think really the problem with D is not understanding structure, okay? Now, what do I mean by structure? We'll get into that, but D is quite serious. This D is really the main reason why a lot of people do all these tutorials and they've kind of got the syntax down, but they still feel clueless at the end of the day. So we'll look at each of these. We'll look at solutions for each of these. But here we're going to watch a quick example I made. It's just me going through a tutorial. And as I said, that'll kind of provide us a way to look at where some of these problems come from. So go ahead and watch and enjoy that. Hello, my name is Billy. I am a 19-year-old student, and I've never coded before, but I heard about this awesome website with lots of free tutorials, so I'm going to get started today. Today's the day that I become a real coder. So I'm starting this project here, step one. Wow, I'm going to build that. That looks really professional. So wow, I'm just going to get started coding, and I feel like I've seen this before. I'm not too sure what it does, but let me just go ahead and follow this example code and type it in. Okay, and there I've got it all typed. Let me see if I got the right answer. Oh my God, I got the fireworks. I'm so good at this. It says the world rejoices. Wow, I'm on such a fast track in my journey of learning to code. Go to the next challenge. Yes, let's see how challenging this is. And wow, I'm already on step 76. This is step 76. I've made such quick progress. And I've got, oh, well, there's so much code here. Okay, now it says I need to add this bottom line to the second HR element. Let me find that. Oh no, I don't have to find it because they've already found it. And in fact, this is the only place I can type. Well, that's great. I can't get confused here. I can't go mess up the code I've already written, and they tell me exactly where I need to do this, so that's great. I can keep making fast progress. So it says, add the bottom line class. You know, I'm a little confused. I don't quite remember what a class is, but hey, it looks like right up here, it says class equals price. Maybe I'll just do the same thing on this little space that they're giving me. Don't really know what that does, but let's see if it's correct. Oh wow, I passed it again. I'm making such amazing progress here, and I'm learning so much. I'll be finished with this beautiful menu in no time. I'm already becoming an expert. So hopefully you found that funny, found that amusing, and it's not hard to see the appeal of learning this way. It's easy, right? You just go through the steps, and it feels good, and they tell you exactly what to do. Because it's broken down into these tiny, granular steps with thorough instructions on every step, you never get confused. It gives the feeling of fast, measurable progress. Everybody likes that. Everybody likes this feeling of going fast. One person I gave this talk to said that he felt addicted to the feeling of fast learning. And it seems like you're really learning because this is all measurable. You can watch the progress bar kind of fill up. However, they're tracking it on whichever site you're using. Percentage done. Some of them have little green icons that fill up, and people love that. And you've also built something. Your code seems to work. You can look at it, and you can say, yes, I achieved this. So it's easy to see why people like this, but many find the results lacking. However, they still keep coming back to more tutorials, which seems a bit paradoxical. It seems a bit maladaptive. So why might they do that? Well, first of all, there's been some research. This is just some information from a book called Make It Stick by Brown. And they've done research showing that students choose ineffective study strategies. This isn't the actual research study. This is a book discussing some of those research studies and the general concepts. But they've generally shown that many students will choose a strategy of learning that feels good, but isn't necessarily empirically shown to be effective. In that particular case, I believe they were just reviewing their notes, reading them over, and they felt very good about that. And it feels very fast and fluent as you're rereading these notes, and that feeling of speed and fluency is something people can mistake for meaningful understanding. But actually, real learning can feel rougher and more difficult, and what they've shown is that people favor these strategies such as rereading their notes or perhaps using a tutorial that gives you a feeling of fast progress, and they kind of mistake those feelings for more robust learning and understanding. And so it's common to think this feeling of fluency or ease indicates understanding, when in fact that's not necessarily true. I also think people may blame one particular tutorial. Well, I did this, it wasn't right for me, so I'm going to this other website or this other module on the same website. And really, you can try that, of course, but after a certain point you have to say, maybe there's a deeper problem, maybe sort of the way you're learning and using these materials is a bit off. And tutorials, most of all, are easy, as I said, and they give you that wonderful feeling of progress, like leveling up on a video game, right? People just love watching green icons appear and bars fill up, or you saw the fireworks in the example video. They're very rewarding in this kind of superficial way. Now, for coding in particular, I think it's different than certain other domains because it's hard to know how good you are, right? How do you know exactly how good you are at coding? So this comes from a few reasons, right? I think one reason is that CS curricula, CS learning materials, coding learning materials, they don't have such a well-defined linear sequence as, say, math does. Math, there's a clear linear sequence that people follow pretty much through middle school, high school, and even through most of undergrad. For example, if you're learning algebra, this is before calculus, calculus is before real analysis, and so on. So people can kind of look at how long they've been learning and where they are on that path. Learning math has these clear mile markers. Computer science and learning to code really doesn't. It's hard to know how much you should know after a certain period of time. And another thing is that people kind of talk about learning stuff in sort of a vague way that I've noticed over the years of teaching. People will say, like, I've been learning to code for 2 years. Well, how many hours per day are you putting in? Okay, because some of them say that, but they put in like 2 hours on the weekend and that's it. Other people are putting in 8 hours a day. Clearly, one guy 8 hours a day for 2 years is very different from the guy just twiddling around with it on the weekend, right? But people talk about it that way, which I don't think is a really accurate way to think about it. And another thing with coding is that none of us really are doing things from scratch, maybe a little bit, but even then you probably have to look a few things up. However, if you have to look everything up and you can't figure anything out for yourself, you don't really know much, do you? So how do you know where you are, right? On this spectrum of I looked up nothing, I looked up everything, you're somewhere in the middle, but how good are you really? It's kind of hard to tell. And because it's hard to tell how good you are, it's also hard to tell if you're making progress, and I think that's part of the reason why people go back to tutorials that they may have found ineffective, is that they don't know if they're making progress, but the tutorials feel good, so they return to them. And again, you can get a lot of value out of online tutorials, but there's right and wrong ways to use them. There's more and less effective ways to use them. As you saw in the video, right? That's a less effective way. So what we're going to do now is walk through those quotes that I had earlier. And for each quote, it kind of shows what I'd say is a different symptom. And so for each one of these, we'll look at what it really means, why it happens based on how people use tutorials, and some evidence-based solutions for how to solve that. When I say evidence-based, some of these D is more based on experience and observation, but the other ones are based on like cognitive science research and learning research that is well attested, that goes back multiple decades. None of it's particularly new, but it is certainly useful. So let's have a look at those. So A, I finished the tutorial and I understood everything, okay? And this sense of understanding is an illusion, as I mentioned. If you really can't do anything with it, did you understand? Perhaps not. Going through the steps and feeling like you understood does not mean you did. As I mentioned, there's this feeling of speed and fluency of going through something quickly that can be thrilling and addictive, but that doesn't necessarily match up with meaningful learning that's going to persist over a long period of time and that you'll be able to use in different areas. And another thing is that, a lot of people would say my code works, so I must understand. And I'd say if you start with like a blank file and type it all in, or you're doing quite a lot of things figuring out for yourself, that's probably true. But I don't think having code means you understand if the tutorial is telling you what to type in at every step, right? That doesn't really indicate you understand, but people seem to think it does. And what would it even mean to understand everything? I mentioned people may not know if they really where they're at in terms of coding. It can be hard to tell how well you really grasp some problem. So what would it mean to say, I understood everything from that tutorial? What would that even look like? Well, I've got some idea, right? What would it mean? Okay, now this is a high standard, but if you're someone who likes to tackle hard problems, work hard, and learn in a really robust way, this is a standard you can set for really understanding something you've learned. Whatever project you built for the tutorial, wait 1 week, don't look at the project, don't look at the code. Then you start with a blank file, you write the entire thing, you get it working, and you don't look anything up other than like minor syntax details or I remember this thing has these 3 parameters, but which one is the first one? Stuff like that, right? So you don't look stuff up other than very minor things occasionally, right? Now, furthermore, you must know exactly why each line must be the way it is. Not, well, I remember they did this on line 1, this on line 2, and this on line 3. I don't really know why line 3 has to go after line 2, but that's how they typed it. No. You know exactly why each line must be how it is. And ideally, for number 4, you can see alternative ways that you could code this, and you know the pros and cons of those. Now, this is a very high standard, and it's probably not practical to apply that standard to everything you do. You'd be working on nothing but starter projects, maybe for 6 months or a year. So maybe this is not realistic to kind of use to gauge your understanding. So how can you gauge your understanding? Well, various forms of testing, right? Now, when I say testing, it doesn't mean sitting down to take like a pen and paper multiple choice test or running through a quiz, but there's other kind of exercises you can do to check, to test yourself. Did you really understand? And testing, of course, is an immensely valuable and time-efficient way to learn, in addition to being a way that you can gauge your progress, right? So A is kind of the easiest, and I'd encourage everybody to do A as you're going through these tutorials. See if you can predict the next step, right? See if you can, for example, say you're on step 75. What do I think they would do for step 76? What do I think they would do for step 77? Then you can kind of check as you go to the next step to see if your understanding is on the right track. B is quite similar, and B is very valuable. It's very valuable to just experiment and explore. So change something and predict what should happen when you change that in the code, then run it to see if that does happen. That's a way of checking if you understand. This reasoning about it is kind of what builds the understanding in you, and then you're seeing if that understanding is accurate when you run the code so that you can adjust it. That's a great little learning loop that you can run through quite easily. And one of the big problems I had with the example tutorial is they only let you, like in that second part where he's putting the class on the HR element, he can only type on that one line. And that kind of prevents people from doing B, and I really don't like that. I think you should be able to experiment more freely, which he could. He'd just have to copy it back into a different file and run it on his own computer, but as a beginner, does he know how to do that, right? So I don't necessarily like the setup where they only let you edit one little line, right? Now, some more time-consuming ways that may also be more effective, we'll look at a few more. We have lots of ways to test yourself and check your understanding and learn in a time-efficient way. Ask why some step must be that way, and then experiment to test whether your understanding holds up. Very similar to B. D, free recall for the key concepts. Now, free recall, the simplest form of that is going to be you run through the module, you see 2 or 3 new things, you close your computer, you pull out a sheet of paper, you write down each of those 3 things and write down as much as you can remember about each of those 3 key concepts that you learned today. That's the simplest form of it. Highly effective. Not relaxing, right? Not easy, but highly effective. A few more that are even better. You can solve problems or write code for projects on the same topic, but from different sources. So some of these tutorials, they guide you a bit too much. If you go to a different source and you can still figure out what to do, that's a good indication that you pulled at least a little more meaningful understanding out of that tutorial. Now, F and G are the best. Use the concepts and syntax to solve your own problems. Kind of take them out of the tutorial context and practice using them. This will be hard, but quite effective, right? And G is also great. It's kind of what I mentioned before on those standards. Wait and rewrite as much of the project as you can from scratch. What does from scratch mean? Blank file, empty directory. If you're doing a project with multiple files, can you set it all up for yourself? Now that's hard. You'll still have to check back for a few things, but I really think if you try that, you'll see it's a great test of how well you truly understand. And knowing how well you understand is a key part of getting value out of these tutorials and of making real progress, because you may see you lack progress and you'll make adjustments, right, to how you learn. Now, let's go on to the next kind of problem that people were complaining about. When I go to write code, I can't remember anything. And this is a problem with recall, right? This comes from a lack of review or a lack of use of either the specific syntax or details or the general concepts. And we've got kind of some solutions that are easy, that are well researched for syntax, and some other stuff for learning concepts because they are a little different, right? And for syntax, you can often just, as the person in the tutorial example did, as I did in the example video, you just kind of glance at what you saw earlier and copy it over. It would be better if you kind of typed it in for yourself without glancing at the previous stuff all the time, right? And it really doesn't help. It doesn't allow you to actively recall the information when the tutorials literally tell you exactly what to type in. And for concepts, many tutorials don't really review these at all. So the learner sees them once and doesn't really have to understand. You remember in the example, the example student, me, didn't know what a class was, but they could still type it in and go to the next step. That seems like a problem. It seems like they should have to understand why they're using this CSS class to move on, but they don't have to. They can forget what it means and just keep typing and keep making that nice, obvious, but illusory progress. So, syntax is easy to solve, right? If you're not remembering the syntax you're supposed to be learning, there's straightforward ways to deal with that. You need to actively review the syntax later, not just reading it over, but making yourself kind of recall it and type it in, and this should feel a bit hard, it should feel a bit effortful. So try to type out that new syntax for yourself in a blank file. Or, as you're coding, say, the next day, just don't be so quick to glance at what you typed in the day before. Try and type it in for yourself, see if you can remember. Now, you're not going to do this all the time, and if you're working, you may have to separate kind of I'm trying to learn right now versus I'm trying to get work done as fast as possible, right? When you're learning, I would try to type it in for yourself and turn off your Copilot or your other AI tools, your completion tools, really try and type it in for yourself. But if you're trying to get work done, switch all that stuff on and, see how fast you can go while still being professional and careful and such. So the syntax you actually use will often stick with you, right? Other people suggest flashcards for this. I have never found a need for that, but if you find flashcards useful or you can't remember the syntax even after using these tips, you can try flashcards. For me, the syntax that's actually useful, you will pick up. And for the other stuff, it's okay to look it up some of the time, right? Everybody does that Nobody remembers every little function and exactly how it works for everything. However, for concepts, this is a bit trickier. And I really think going through tutorials with no meaningful conceptual understanding can be a huge problem in terms of the learning process. So, in some ways, this is due to what tutorials online are. They can't really require you to understand concepts because they are automatically graded. They're automatically graded either based on what you type in or based on what your code outputs for a given input. And so they can't really check that you understand these concepts, so you can kind of breeze over that without ever reviewing them or using them or applying them or developing any meaningful understanding. And the concepts are the most important part, right? So that's kind of a flaw. You'll learn different languages, work in different areas, but those deeper concepts are what's going to stick with you. So it's quite a big problem for these tutorials to not really require you to apply the concepts as much. So how do we deal with that? Well, what we need is a way to review the concepts, ideally multiple times. So, number one is my favorite way to do this. This is something I do all the time for almost anything that I'm learning. Write questions for yourself. So you're going through a module, let's say you're learning about Python coroutines, right? So you might write some questions like, how is a coroutine different from a generator? What are some use cases for coroutines? How is the yield keyword used? And so on. And then later, like the next day, you can go back and answer those questions to check your understanding. And you can keep these questions in a file that you save on your computer or wherever you save things and look at it later. Use a notebook if that's what works for you. But this one's very easy and generally effective, right? And if you really want to go hard here, you could do stuff like review the questions after a week, then after a month, then after like 3 months, for example. That'll really lock them in quite well. And that this does not take that long. It could take 10 or 20 minutes a day. It's not too much. Number 2 is critical also. Write your own short programs that use or rely on the concepts. Of course, you're coding. You need to do that. And I think drawing or writing about how new concepts relate to code, kind of identifying places in the code where the concept is applied and why is quite critical. And also connecting it to concepts you know already will help you integrate and retain that information. And finally, you can write out your own explanations of key concepts, and you can do this both after a lesson and after time has passed. Waiting a week, for example, and then writing about the concept to really check how much you know, but that will also just kind of get it to be more durable in terms of memory and recall for later. Now, how do you know if you're doing it right? Get a friend to check if you have a friend who's good at coding and they have enough free time to help you with this stuff. If not, I really think GPT is okay here. For just sort of beginner level concepts, GPT is quite accurate. And GPT, you kind of noticed, you can use it in 2 different ways. You can use it to generate things that are completely new, or it's also just kind of a way of organizing information that's already commonly known and commonly out there. For that second one, I feel like it's good enough. Is it going to be flawlessly accurate? No. Is it going to be accurate enough to be useful? I think yes, right? I would say yes. Just keep in mind it can occasionally be wrong. Now for coding, like actually writing code, that's different. But for general review of basic concepts, I really think it's fine and it's good enough. Now C is kind of a trickier problem. And C, I really think, is points to deeper issues with how these tutorials are set up. So C says, I couldn't figure it out, so I looked at the solution, and they call this random function. And it's like, how am I supposed to know that that's what I should do there? It's a big problem. And they just feel, the user feels like they have no way of knowing that that's what they're supposed to do. And this boils down to, I think, a failure to recognize situations, right? They cannot go outside the tutorial and spot situations where they should be applying these, or even further on in the same tutorial or with a different module from the same site. They cannot spot these situations where they need to apply concepts they picked up earlier. Now, why does this happen? I would say it boils down to too much guidance. as I've mentioned, I don't like the way that tutorial gave them the exact line for where to type. It would be much better if they kind of forced them to find it. That's what I'm saying here. Like, if you're always telling someone where something should go, how will they learn to find it? Doesn't make sense, right? That's like people who drive everywhere using their GPS and they can't even go to like their normal grocery store with their GPS off. That's awful, right? If you're always telling someone exactly where to go or exactly where to find something, how will they learn to find it? Finding the right place in code to apply something is like so core, right? It's so core to what writing code actually is. It's not just typing, guys. And so being able to read blocks of code and be like, I need to change this part, finding that part is so key, but I think the tutorials guide you a bit too much, and so it can feel like finding this place and applying the right concept can feel kind of random and overly difficult, but it shouldn't, right? It shouldn't. Think about this. If the tutorial didn't tell learners where to type, they would feel confused. But that's kind of good in a way. I actually think you should feel confused sometimes when learning. You shouldn't feel totally lost all the time, but some confusion is good because you have to step back and really think about it. You'd have to say, okay, what concepts have I looked at? Where did I use those? Where did I apply this? Have I seen any situations like this? All of that thinking is where the real learning takes place, guys. So that confusion in a way is kind of good. And, they need to compare and consider various concepts. As I said, that's where the real learning takes place. But we have solutions of this. We have solutions to this. Here's some general advice, and then we'll look at some more specific kind of research-backed solutions to being able to apply concepts in more different situations. So be wary of tutorials that do the thinking for you. You could see that the simple tutorial we looked at in the example, it kind of just did the thinking for you, told you exactly what to do at each step. You didn't have to figure out what to do. I think a huge number of steps for basic projects is a red flag. Why? Because they've broken things down in too simple of a way and you won't have to reason about it as much. I would say favor tutorials that tell you what to achieve rather than exactly how. So for example, add a button to delete an item versus add the CSS class delete button to the div on line 47, right? This one, the first one, is better because you have to think about what to do and where to do it and how to apply it. The second one is essentially just typing, right? It doesn't really require you to understand anything. And of course, C is just general advice. Pay attention to the general concepts and the structure of the problem, making notes and reviewing, and then try and apply those to new problems. That's just general learning advice. We do have some kind of research solutions to this issue of not being able to transfer and apply things. So interleaved practice basically means you take about 3, 4, 5 different concepts. You do one quick practice activity for the first one, for the second concept, for the third concept. You're rotating between concepts. What you do is get these practice exercises, and then as I said, you rotate through them. Short but active exercises, probably writing code or perhaps answering conceptual questions, not just rereading stuff. And so you rotate between them. And use concepts from the same subject, right? Don't do this for like one concept from coding and one concept from art history or whatever you're learning. And they've got research indicating this is effective. Benefits for memory and transfer. Memory, remembering it longer, but transfer just means you're going to be able to apply it in more different situations, and that's hugely important, right? That's what we want. Here you could see they found quite a big difference. Now, not all the studies had such a big difference. Some of them were like 63 versus 55, but quite big differences in this case. And just better recognition for a wide variety of things. Now, why does this work? The basic idea is that you are learning differences between categories, between concepts and situations so that you can apply these things, right? You're focusing on differences and distinctions as you alternate between and rotate between the different concepts, right? For coding, this would mean you're more able to look at a problem and identify which concepts, which syntax, which functions, whatever, to use, okay? And tutorials can sometimes leave that out. Now, varied practice is similar. I won't spend too long here, but this is just using slightly different problems for the same concept. So interleaved, different concepts one after another. Varied is slightly different problems focusing on the same thing. So you can use different sources, different contexts. This can be quite effective, and that should improve transfer, right? And here's just some research. I won't go over it in detail. That one, though, over 1,000 students. That's quite robust. That's a lot. And so D, we are on to our last complaint. Whenever I see other projects, I have no idea where to even start. This is quite serious, right? Not having any idea where to start, well, it feels like you're at a loss, right? It feels like you did all this and yet you still can't even take the first step on a new endeavor. That's a terrible feeling, but this is a very common complaint. Now, I will say, to some extent, this feeling is normal. It's normal to be confused. Figuring out how you should set programs up is quite challenging. And it's quite normal to consider multiple options, and in fact, I'd say this is kind of the default. This is how it usually is. When you're setting something up, you might consider multiple options. You might choose one and later figure out that none of your options were right, and you have to make changes to the deeper structure of the program. You may also have just chosen a project that's too difficult, but if it's similar to what you've been doing, you should have at least an idea of the first few steps or the basic structure. So if you truly have no clue whenever you start any new project, I think this indicates you did not learn the structure well. Now, what do I mean by structure? So tutorials do a bad job of teaching this, but by structure I mean large decisions made as you are starting the project about how to organize it, how to arrange it, and not just when starting the project, but also later as you kind of make adjustments to this. Stuff like architecture, design patterns, kind of what your top-level classes are, how your files are going to be set up, and stuff like that. Now, many tutorials give you pre-made sections or starter code, which I think is perfectly fine up to a point. It's fine because it helps you focus on the things you're learning, but at some point you have to step back and kind of start setting things up for yourself, right? Not just filling in the little pre-made sections they have for you. Because going from typing in this little box they give you to actually making real decisions about how to set things up is quite a large leap, okay? It's quite a big leap. Now, tutorials may mention why they structure things in a certain way. However, just like with the concepts, they don't, these are concepts, but they don't really force you to know that, right? You go through, okay, this is how we set it up. You go to the next step and they've already set it up for you. You go to the next tutorial, they've set it up for you. They'll tell you about that, but because they don't require you to do any of that on a lot of these tutorials, you're not really going to understand it and maintain that sort of skill set of being able to analyze and set up new projects, right? Now, it is hard to pick this up. What people do classically is they draw out the structure. So what are the different main parts and how do they fit with each other? I enjoy drawing. I actually think it's nice to step away from the computer sometimes, pull out a blank sheet of usually printer paper, and kind of draw out how things fit together. I've always liked that. So, and that's a real skill too, right? People do this during interviews, during meetings. Drawing out the structure of programs is actually a real skill that's definitely worth practicing and developing. And really, I think ideally, as you draw this out, you might write out why it must be structured in some certain way. And they do have research saying that drawing is quite effective as a learning strategy. Now, if you look this up, you may find out about UML. UML is kind of a formal, technically specified way of doing this. A lot of people don't like UML. It's not used as much as some people may act like. So if you look at it, you think it's interesting, you can learn that. I wouldn't say it needs to be a focus, right? I wouldn't say it's a priority. People draw it out in different ways. That's fine. You don't have to learn this formal way if you don't want to. And how can you practice this, right, in a bit more detail? So I would say the first step is kind of making predictions, as I talked about earlier. But when you read the project description, write out or better draw how you would organize it. Then, when you look at the actual project in the tutorial, see how they did it, see how it differs from how you did it, and understand why, right? Understand why their approach might be better, understand the pros and cons of the way you structured it versus the way they structured it. And if you're serious, you can write out two options and kind of compare them before you look at the solutions or before you go on. This is a tip from the book A Philosophy of Software Design, and this guy who wrote it is a Stanford professor who teaches design, so you should know, right? Now, having said all that, I think this design and structure and architecture are quite difficult to learn or to teach in a free online format. I just don't know if auto-graders and multiple choice quizzes are ever really going to be able to test your understanding of this in any meaningful way, right? It's difficult, structure is hard, and it can take years to master, if ever. Even for people who are experts, the best solutions are really never obvious. So try your best here, and don't be too hard on yourself. But if you're serious, you should have common patterns in your chosen area memorized. Whatever you're specialized in, have the common patterns and setups memorized, but more importantly, know why they must be that way. That's the key part. But given that learning from tutorials and courses does have these limitations, how can we go further? And I think this one's pretty obvious. This is the most obvious suggestion you'll get if you ask people online, how can I best learn to code? They'll say this: build your own projects. And I think this is mostly correct. Here's the thing. I think using a tutorial or a course to get all the basic information is good. Or if you have some specialized area, getting the basics on that specialized area from a rigorous, difficult course is good. But I would say building your own projects, you kind of have to go out in the wild and forge your own path at some point, and you'll really notice that as you do this, you integrate a lot of information quite quickly. This is also better for building your resume or CV, and you can put it on your GitHub. And I think if you look at this from a learning perspective, if you look at building your own projects from a learning perspective, it actually makes a lot of sense, right? Why? Well, building your own project satisfies many principles of effective learning. For example, you are going to be applying concepts over a period of time, over a period of weeks or months as you're building this, so that's spaced repetition. You are doing active recall as you actively remember these things, and you're generating the code yourself, which is another effective way to learn. You're interleaving because you'll be applying different concepts one after another as you set these things up, as you solve these problems. You're applying the same concept in slightly different concepts, so that's variation. And number 5, let's not overlook number 5. If you're building a project that matters to you, you'll enjoy it more, you'll be more engaged, and this likely can lead to better learning. For example, as a comparison, why is it so easy to learn all these statistics and properties and strategies for your favorite video game or your favorite real game or your favorite sport, and you remember it so effortlessly, but with academic stuff, it's often so much harder to retain this stuff? Well, for the games, they're just more engaging, right? And so if you choose a project that you like, you can bring that benefit of engagement to your learning to code. So let's review. I mean, you can pause this and review if you want. If you're serious about this, if you want to actively learn, go ahead and pause the video. And for each of these, think about why it happens and just think about one way to deal with this. And if you have questions, you can put them in the comments. But I'm not going to go over this. You can rewatch the video yourself if you'd like. But you should actively review, right? So that's going to be the end of the talk. I want to thank you very much if you watched the whole thing. My name is John. I am at Code Slate Tutoring. If you're looking for a tutor or know somebody who is for learning to code, go ahead and check out this website. You're already on the YouTube. You can subscribe if you want. I also do animated videos about computer science concepts. And if you'd like to come to kind of a live lecture to this kind of content in a live format, next one should be January 28th, 2025. Oops. Okay. 2025. And the links to the meetup groups where I host these things is in the video description. Thank you very much.